my name is Christine, and this is my video on a homework problem. So the problem I chose was the one with 3 cylinders with one stacked on top of 2 others. So here I have the structure drawn out here. We have the 3 cylinders with 3 different normal forces labeled, and I have an external force pushing on the 3 cylinders. So we want to find the minimum and maximum force required to keep the cylinders together. Basically what the problem asking us is that when the force is too low, then one of the normal forces becomes 0. And the force is too great, another normal force, a different normal force becomes 0. And we want to use that information to be able to solve the problem. So let's solve the maximum F case first. So in the maximum case, if the force is really great, what happens is these 2 top cylinders rotate up, and this normal force, N3, labeled here, becomes 0. So if we just isolate the top cylinder, we can solve the problem. So we assume that all of these cylinders are identical and have a mass m. So we have downwards gravity, mg, and we have upwards normal force, F1, from this cylinder. And let's take theta to be 30 degrees. This is theta here because it's an equilateral triangle. So this is theta, this is theta. This is n1 cosine theta, and this is n1 sine theta. So we set n1 cosine theta equal to mg, and we use that to solve for acceleration. So n1 cosine theta equals mg because there's no change in the y components. You assume that this is at the initial moment when force is too great, and we took theta to 30 degrees, so cosine theta is just 3/2. Thus, n1 is 2mg over √3. And since we took a case when force just becomes too great, we know that n3 here is 0, and that's how we know we're solving for the limiting case. And then in the x component, we do n1 sine theta equals na. We can plug in n1 here to get acceleration. As a result, we get that A equals gravity over √3. And this is the greatest acceleration that all of the cylinders stick together. Now let's find the minimum. So to find the minimum, we have to think about the problem conceptually first. When force is too small, what happens is the 3rd cylinder falls down, so normal force N2 becomes 0. So let's first look at the top cylinder again. We have mg, but we also have 2 normal forces. Once again, the y component doesn't move because you're looking at the moment that force is too small. So n1 cosine theta plus n3 cosine theta equals mg. So this is n1 cosine theta, n3 cosine theta equals mg. And then we grab the x component too. n1 sine theta plus n1 sine theta minus n3 sine theta equals ma. So this cylinder is still accelerating because of the force F. And the difference is that because it's moving in this direction, the n1 sine component has to be greater than the n3 sine component, which leads to this subtraction equation. And then given this, we can isolate n, but it's we can isolate n1, but it might be easier if we look at this in conjunction with the bottom cylinder. So the bottom cylinder is mg down, and then normal force 3 here. And then with this cylinder, we just only care about the x component. And what happens is that n3, and assuming theta is 30 again, n3 will equal n3 sine theta equals ma. So now I'm going to plug this back into this equation. So we have n3 sine theta equals ma, and we also have n3 sine theta equals ma here. So I'm just going to do n1 sine theta equals 2 n3 sine theta. Sine thetas cancel out, so we get n1 equals 2 n3. Plugging this into here, we get 3n3 cosine theta equals mg. We know cosine theta is root 3 over 2. So we get n3 equals 2mg over 3 root 3. Taking this back into this equation.
You challenged me for my account, right? And I go on your account and play. And
No,
then
I was gonna challenge me, right?
We get a
Your account and
equals
play
g3
Yeah, so I would have
over 3 root 3 or g root 3 over 9. And you can't see that, so I move this video over. So basically we found the minimum and maximum cases of acceleration so that the entire structure sticks together. We have, for the minimum case, we found that acceleration needs to be greater than g root 3 over 9, and for the maximum case, acceleration has to be less than g over root 3. Thanks for watching.